Hello and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to continue what we started last lesson. It's about the acids and bases. Today we're going to focus on the electrolytes, weak acids, and weak bases. So let's get started. Weak acids and weak bases. Strong acids and strong bases are strong electrolytes. We need to know what strong electrolytes means. Weak acids and weak bases are also weak electrolytes. But what is an electrolyte? Electrolyte is any substance that dissolves in water and it has the ability to conduct the electric current because it consists of ions. So when it dissolves in water, it will give away those ions, the negative ion and the positive ions, which are responsible for conducting the electricity. So for example, if we have sugar here and you put it in water, it will not conduct electricity because sugar does not have ions. It will decompose, it will dissolve in water, but it will not give you ions. Whereas the salt, for example, NaCl, it consists of Na positive and Cl negative. When you put it in water, it will dissolve, it will dissociate, and it will give you Na positive and Cl negative, as you can see here, and it will conduct electricity because Cl negative, it will go to the positive pole, and the Na positive, it will go to the negative pole. That means the electricity was conducted. Now, weak acids are weak electrolytes. Weak bases are weak electrolytes. We have something called the acid ionization constant for weak acids because in the previous videos, when we solve, for example, for a strong acid, I'm going to write it here. Let's say HCl is a strong acid. And it dissociates in water 100% because it's strong to give you H positive plus Cl negative. And that means the concentration of HCl in this case is equals to the concentration of H positive exactly. But in the weak acids, for example, if we have HF, this is a weak acid. And that means weak acid does not dissociate in water 100%. And it dissociates as a reversible reaction, as you can see, two arrows. And it will give you H positive plus F negative. And in this case, the concentration of HF does not equal to the concentration of H positive. In general, if we have a weak acid, for example, which is HA, it will decompose to give you H positive plus A negative, the conjugate base. We have something called the acid ionization constant, which is Ka. And we know that the constant it equals to, at equilibrium, it equals to the concentration of the product divided by the concentration of the reactants. So that means the K for this reaction, it equals to the concentration of H positive multiplied by the concentration of A negative, this one is negative, sorry, divided by the concentration of the acid, the weak acid, HA. There we go. In this case, because we are talking about a weak acid, also this one, so we're going to give it the letter Ka. So from now on, Ka equals to the concentration of H positive multiplied by the concentration of the conjugate base divided by the concentration of the acid. This table is very important for solving the problem. Usually in the MSAT exams, in the AP exams, also in the ministry exams, you will have those kind of tables, the constants of the weak acids. Or it will be given, like for example, Ka equals 2 and they give you the number, if they're not asking you to solve it. So for example, we have here HF. The Ka, it equals to 7.1 times 10 to the power of negative 5. We have, for example, for the formic acid, we have it 1.7 times 10 to the power of negative 5, etc. Now, how to solve the problems for weak acids and weak bases? Let's start with the weak acids. In the strong acids, we don't need something called Ka because the reaction is irreversible. It's one direction, and the concentration of the acid equals exactly to the concentration of the H positive ion. Here we have steps for the weak acids. The first step is to identify the measured species that can affect the pH. Of course, it's going to be the weak acids, not the water. Then we need to use something called the ICE table to express the equilibrium constants or concentrations in terms of the single unknown X. Then we need to write the Ka, and then we need to measure or calculate the approximation, and I will tell you what is the approximation. Later on, you will find that it should be less than 5%, and you will understand it later. Number 4, we calculate the concentrations of all the species, and as well as the pH and pOH of the solution. Let's implement those steps to calculate the following examples. The first question is, calculate the pH of 0.036 molar nitrous acid HNO2 solution. We know that the nitrous acid is a weak acid. That means it has a Ka. Therefore, we cannot write the dissolving of the HNO2 as a forward reaction only or irreversible reaction. The first step is I'm going to write the decomposition or the dissolving equation of HNO2. And it's going to be reversible reaction and give you H positive plus NO2 negative. Now, I need to use the ICE table. ICE is I for the initial concentrations. The C is the change, and the equilibrium is E. Now, the initial concentration of HNO2 is 0.036 molar. And the initial concentration of the H ion, H positive, was 0 before the reaction, as well as the NO2 negative, so it's going to be 0. In the change, I'm going, because HNO2 is being consumed, is being dissolved in water, so it's going to be negative X, because 1 mole, and for the H positive is going to be positive X, and for the NO2 is going to be also positive X, because 1 mole, 1 mole, 1 mole in the stoichiometric. Now, in the change, we need to add the initial plus, in the equilibrium, we need to add the change and the initial. So basically, it's going to be this step plus the second step, we add them together. So it's going to be 0.036 minus X, and here is X, also X. Now we have the concentrations, as you can see here, in terms of single X. Only one unknown we have, which is X. Later on, we're going to write K A for the weak acid, which is HNO2. It equals to the concentration of the products divided by the concentration of the reactants, which is H positive multiplied by NO2 negative 1 divided by the concentration of HNO2, and which equals to, we have the concentration of H positive, which is X, multiplied by the concentration of NO2 negative, which is also X, so it's going to be X squared, divided by the initial concentration or the equilibrium concentration of HNO2. Never do this mistake. We don't write the initials, we write the equilibrium. So it's going to be 0.036 minus X, and that's it. From the table that is given in the exam, or from this table, here we're talking about the nitrous acid. So we need to find the nitrous acid here, and you find it's right there, which is 4.5 times 10 to the power of negative 4. So this one equals to 4.5 times 10 to the power of negative 4. Now, in this equation, we have only one unknown, which is X. And now we use the math to solve such an equation. Now, initially, what we're going to do is to ignore or to neglect this X because it's going to be very small. So it's going to be X squared divided by 0.036 equals to 4.5 multiplied by 10 to the power of negative 4. That means we can find the X now. Cross multiplication, square root, you will have X. Now when we have X, this is the concentration of H positive at equilibrium, X. Let's say it was 2.3, 1.7, whatever the number we have. I'm not going to do the math, you double check it. The question is asking you how to solve, or they want you to solve or to calculate the pH for the solution. Now you have the H positive, that means pH equals to negative log the concentration of H positive, which is X, which you already have. And it's going to be simple. I want you guys to pause the video, try to solve this problem here, and we're going to continue next video. That video was very short because I just finished from my school, and I will promise you to do another video today about the weak acids and weak bases, because next step is going to be the weak bases. We're going to solve a problem about it, and that's how we finish the electrolytes, and we're going to start solving some problems from previous exams. I hope you guys learned something new today. Have a good day. Bye-bye.